Hello everyone, a new episode, and at the end of the last one we said this one would be about controlling the gems. However, I think we need to do something first, and that is actually spawning a column of falling gems for us to control. So if you look at what we currently have, okay, so we have gems that can fall until they hit the floor or until they hit another gem. But now the game is stuck because there are no more new gems falling. So what we want is that once we get into a stable situation, that we get 3 new gems falling down as a column. I think from the center of these columns. So let's get started on that, and that means we can start with creating a test that says something like, let's see, so create a new mark for spawning new gems, and we'll create a test that says a new gem spawns when updating a new board. So we'll create a new board, then we'll update the board. Oh. This should be this board, and then we can assert that our updated board gems.count is more than the original board. So we should have at least a single new gem. Let's see. It would help if we actually added this test to our tests file. I thought we had it open. Okay, so let's give it a go. So let's run this test. Now the test fails, which is obvious, and we can fix this by just saying, what if we just added, we take our updated board, we take the gems, and we create at some position a new gem. Now this test passes. However, this will create a gem every turn or every update. So we should check that a new gem doesn't spawn when another gem is falling. So we only want to spawn a new gem if there's actually nothing falling. So we need again a board, and this board will have some gems, or at least one, for instance 0, 1, and this can be a red gem. Then we take an update and create an updated board as the board.update. And then we can assert that our updated board gems.count is still 1. So no new one should be spawned. Let's run a test. And it fails. So we somehow need to keep track of the fact whether a gem is falling. I think the easiest solution is to simply check if a gem has fallen. So we create a variable called gem has fallen, and we'll initialize it as false. And if a gem has fallen is still false, then we spawn the new gem. And if here we are actually moving a gem down, here we can say that a gem has fallen is true. Let's try running the tests again. Okay, now all the tests pass. So this means that if we actually build and run, we should see a single gem getting spawned after everything is stable. So everything is still falling. Now we're in a stable position and a new one spawns, although the choice of doing that at position 6 wasn't very smart and are only green, but so far so good. This is the basic behavior working. So let's at least make sure that we spawn more or less in the center. And let's continue. So I don't want to spawn just one gem. I want to spawn 3 gems. 3 new gems spawn when updating a stable board. So again, we need a board, and the board will have at least a single gem already. This can be again a red gem, and then we update the board, and then we assert that the updated board.gems.count is now 4. So the existing one and 3 new ones. So let's run the test. And this one again fails. What I'll do is I'll create a separate method to spawn the new gems. I will call this one spawn new gems. It doesn't really need any, it can be private. It's mutating and doesn't need any parameters, and we can just say we have at y 13, 14 and 15, and now we have, well, let's make it a bit more interesting and have a purple one and a yellow one. And now we should call this function on updated board, and now the test passes. One other refactoring is I want to put this one below, so I want to have the overview first and then the detail methods below. Okay, you can actually see this in the game as well. So these things are still falling. And now 3 new ones spawn, but as you see, something interesting is happening. There's a gap between them, and that's not something I want. I want them to fall as a group. And that's not something we're testing for currently. So I'll create a new test that says 3 new gems fall as a stack. So they fall together as a stack. We create a board. A new board immediately call this update function. Then we'll update it again. After this update we have falling gems. And then we say board.update. And then let's assert that on our updated board, gems vector at 312, one down, is not nil. Actually, we can assert not nil. And we do the same for 13 and 14. Let's run this test. And this test fails because there is actually a gap introduced now, for instance, at the place of the second one. So how can we solve this? Well, the problem is our gems are being evaluated for falling down in a more or less random fashion. So I'm looking at all the gems in this dictionary, and the sequence I get them back in is more or less random. At least it's not determined and not in any particular sequence, meaning that it's very well possible that the second one, let's try and show this. Let's say we have two gems, a green one and a red one. Let's say the red one tries to evaluate if it can fall down first, then it sees the green one and determines it can't fall. While as first the green one falls, then there would be place to put in the red one. We solve this by evaluating from the bottom to the top. So we start at the bottom, try and move everything down, always making place for the one that is one further down, and we go from there going up. This requires a slightly different setup. So what we'll do is this. We'll go from, we'll evaluate y from 0 to 16, because 15 is the highest place that there can be a gem. Then we evaluate from left to right. And then we see which coordinate we get. So we'll create a vector based on these x and y positions. And then we see if we have a gem there. And this needs to be on the updated board. Oh, I'm sorry. Here. Then if this is okay, and we can move down. This is the code we had before. So this is our coordinate. And a gem. We should be able to get rid of all this code. And this should now work. Let's see, what am I missing? Oh, this needs to be done on the updated gems. And now the test passes. I think if we run into the game, we will see that it works. So let's quickly check. So this now seems to be working correctly. Okay, let's see. Now this code here is getting a bit messy, so I want to refactor a bit further. Now we're in a green position. We can get rid of this one for a bit. Let's see. So the first thing I want to do is I want to take out the spawning of a new or the moving of a gem down. So what I'll do is I'll refactor and extract this one to method, and I'll call this one move gem down. This will take a coordinate and a gem. And this can be a private mutating function. Again, I want to have it below, and we'll call this function on the updated board. Okay, so this already I think will make it look slightly better. If everything goes okay, all tests still pass. And now I want to go one step further. I also want to make this a bit more better looking. So I want to extract the function that checks if a gem can fall down. So I want, but this one I think I'll create manually. We'll have a private mutating function move gems down where possible, and this one returns a Boolean value. And all this stuff I want to put in here, although we can now get rid of the updated board. Let's see if there are any left. And this one needs the variable. And then return the variable. So this is a function that both returns a value as well as has a side effect. Normally I'm not a big fan of this. Normally I either prefer functions to just return a value but don't have any side effects, so don't change any internal state, or only change internal state and then don't return anything, because then it's obvious that it should, if it's not returning anything, then I expect it to do something else, to have a sort of side effect. However, because this is a structure, we have the mutating keyword here already, notifying me, well, this will then definitely have some form of side effect, otherwise this would not be necessary. So that's the reason why I do accept it in this case. And this means that this code can also become a bit easier, because what we just say is let a gem has fallen be equal to our updated board, move gems down where possible, and I think the test should still pass. Okay, cool. Can also run it in the game. And this should also still work exactly the same. Now what I want to do is I want to randomize the gems that fall down. And to do so, I'll go to the definition of our gems and I'll add protocol conformance to case iterable. And this means that you get a sort of free array generated by the Swift compiler that has all these values in it. And we can use that to spawn random gems, and we can do that here. So instead of using these hard-coded ones, we will say gem.allCases, and then take a random element. And now we should get different colors. Our board currently has a couple of standard default gems. We can just get rid of these now, because we have the core loop of spawning new gems available. So this time it's just it's a red, a green and a blue. However, next time it could very well be 2 pinks and a blue, and now perhaps some others. So now we have random values. Okay, let's see. I want to do one further refactoring, and that's this. So we have a definition of column count and row count in our game scene. However, our board has fixed values for column count and row counts, and I think it would be, in this case, more useful to define them on the board and use them in the game scene. So let's get rid of these two and add them here. And then we can just use here the board called town and row count. And let's see if there are any other places where this matters. Well, let's just build and run. Okay, so this more or less works the same. Okay, we can also get rid of this dead code. Let's see if there's any other dead code that we can get rid of. I don't think so. Okay, so we now have the spawning of a new couple of falling gems. Next time we're going to work on controlling the gems, in particular the move left and move right functionality. And yeah, this time for real. So thanks for watching and have a good day.